So hello, everyone. Thank you for showing up here. This is, I know, the last session between you and drinks and food and such. So that's a big motivation. So I could keep this very short, or I'll try to tell some interesting, colorful stories also. Thanks for being here. Obviously, if you're here, you're interested in what we're doing, Meta, around Llama, why we open sourced it, what it is, where we're going with it. Maybe some of you have already experimented with it, either by your own private instances or on the Databricks Mosaic platform. So if you're here, of course. So I wanted to give just a little bit of the story behind the story, right? There's a lot of things that people really don't understand why Meta, a company that's really big and developing large language models and in the future multimodal models, why we're doing what we're doing right now. And so a little bit of view into that, a little bit of what we have, what we've released, how we're approaching testing, et cetera, and then eventually even a little view into where I think we're going. So again, I run our AI partnerships team. We do a lot of various different things with a lot of different tech partners, and so Databricks has been one of our close partners in working to help enable and support customers and users in using Llama, and so this is one of the reasons why they invited us up here. So we say that we really like an open approach, and really the open approach towards LLMs and language models for us, the kind of the idea behind it is no different. The benefits are no different than, in some sense, open source software. It's a little bit different. I know it's not code that you compile and run. It's a model that you potentially post-train and fine-tune and run, but a lot of the benefits are the same, and including from a kind of a community end user perspective, from a corporation perspective, open really does drive a lot of benefits. By running the model, you will find errors and hallucinations. These things are prediction machines at the end of the day, right? And so we have a GitHub where we are actually starting to now see so many kind of errors and reports coming in that we then investigate, and we're actually took some of those errors and fixed them in the pre-training data for Llama 3, the thing that we just released. And we're going to do that again for Llama 4 and on and on. And essentially, as long as we keep open sourcing the next version, those fixes are built in, right? It helps you for your next version. It doesn't help you for this version, but it'll help you for the next version. And so these community-driven improvements to make the model better is actually a real thing, and it's happening on Llama. There's also, very similarly, safety and security. I'll talk a lot more about safety and security, but kind of the same idea of how do you make sure these models are not responding to prompts that are malicious or trying to get around and circumvent their safety mechanisms. The third, this is not about the model itself, is obviously the ability to use the model the way you want it anywhere, right? So you can use, of course, one of the Llama models as is, but one of the really, really interesting things about it is that because it's an open weights model, it's an open model, you're able to take it, you're able to fine-tune it on your data, and the resulting model, you can actually have it anywhere you want. You can have it run as an API and a hosted API with a partner like Databricks. You can have a private instance with a partner like Databricks. You can even have it on-prem. You can actually move that same model. It is your model, right? And so I say data privacy, but really is the model modularity that you can mix and make sure that your data is going into that model and only your model itself. And then finally, really cost, right? At the end of the day, if we're providing it at no charge, you are paying for the compute. You can't get away with the compute. Inference cost is important, right? And I want to talk a little bit about that a little bit later. But the fact that we're not charging money for the model itself helps reduce it to just focusing on the inference compute cost. So you might be thinking, well, why would Meta actually release the model, right? Well, a couple of reasons. Interestingly, the first two reasons and benefits to us are exactly the same that are benefits to you. I mean, as you're helping make errors and hallucinations and fixes, that helps the model, that actually helps us. And this is the same, we've learned this, or we have a culture at Meta for many, many years of doing this with open source projects. Many of you have worked in the mobile app ecosystem, you know about React and React Native. And that's a great example of how we contributed to a project, open sourced it. We still are the major contributors, but we benefit a lot from features and bug fixes there. Similarly, not at the model layer, but in AI, PyTorch, which is used really for model development, fine-tuning, and model execution for many types of models, not just LLMs, is a project that we open source, and we love what's going on with that as far as the code base. And so the community improvements, the community finding safety issues, these are actually all good things, because that means the next version, today it's Llama 3, next version is Llama 4, just gets better and better, even for our products. The nice thing is we don't actually have to make money on the model, right? We're in a very unique situation. There aren't very many companies that can do that, but we don't have to make money on the model, and so we can actually provide it free of charge and try to drive these benefits. There's also, from less so many of you who are probably working in corporations using the model, there's also the entire silicon industry and the cloud industry are looking to ways to performance optimize the model. And there are things in running the inference of the model that we've been able to even leverage in our own data centers for running Llama, which has been great. And last but not least, hey, let's be fair. To have the best R&D team, the best AI scientists and machine learning engineers, everybody wants to work on things that have the most impact. And it's a good way to attract talent as well, right? You want to make sure that, hey, you can work on models that we're going to use inside our products, like our Meta AI assistant, but it will also be used in a slew of other products across enterprises and startups. And so our motivations are actually, very clear. We try to make it, we're not doing this just out of the goodness of our heart. We're doing this because it actually helps us too, right? It really helps us while it's helping the broader ecosystem of companies. So what is it that we released? Well, last year, a long time ago, we had something called Llama 1, which was a research-only license associated with it. And we saw the input from so many companies. Myself and my team actually got input from banks and life sciences companies and car manufacturers. It was just wide diaspora, not just the tech companies, right? Coming to us say, hey, this language model is really good. Can we have a commercial license to it? And we're like, no, we didn't think about, this is Llama 1, right? And so as we were training and building Llama 2, one of the things that we thought about is, hey, maybe we should open source it. And fast forward, of course, we did open source the models itself. So Llama 2, if you look back a year ago, what we released was both the pre-trained models, and I'll talk a little bit about the differences there, as well as the fine-tuned models. The fine-tuned models, the first is the chat model. The second we released is a set of coding models. And then last, we even released a safety model. And I'll talk a little bit more about the safety model later as well. You don't have to memorize this, but we released all those. More recently, just in a few months ago, we released Llama 3. And Llama 3 is a huge improvement over Llama 2. I don't need to tell any of you that this space is moving so quickly. I work in the industry every day, and literally every 2-3 days, I can barely keep up myself about new news or new innovations going on in the models or new industry news itself. And so, from when we released Llama 2 in July of last year to April of this year when we released Llama 3, the level of improvement is just pretty amazing in the model architectures. In Llama 3, in April, we released 2 models, the 8 billion parameter model and the 70 billion parameter model. And we released 2 flavors of that. One, which we call Instruct. Before, we were calling it the chat model, but it's not really correct to call it the chat model. You have this foundational model, but then you fine-tune it. That fine-tuned model can do a lot more than chat, right? It can summarize things, it can write copy, it can do basically kind of a search, it can create, things. So it's not really a chat model. So we moved back. We were trying to be more consumer interesting, but we moved back to calling it really what it is, which in the world of AI, models, most people call it instruction following, right? You would take a more raw model and you make it instruction following. Very geeky, I know, super geeky, but now we call it instruct. So we've raised the white flag and said, okay, we're just gonna call it instruct because it can do a lot of different things. So if you think about it, we have a pre-trained model, the raw model that we did release for both weights, as well as the instruct model. And we've released something called Llama Guard. I'll talk a little bit more around safety and all the things we're doing around that, about what Llama Guard is. Now, compared to Llama 2, July of last year, to Llama 3, April of this year. By the way, obviously if you have a system built on Llama 2, you're probably still using it. But if you haven't, you'd probably start with Llama 3, of course. But compared to that, in just 1 year, there's so much that's changed. First of all, inside the model architecture, a variety of things have changed. I can't really describe that in gory detail. But maybe some of the most important things are as follows. Number one, and probably the biggest, is the number of, the amount of data we used from the pre-training stage to train the raw, what's called pre-trained model. We went from 2 trillion tokens, and a word is about 2 tokens, right? And of course, images and text, or images and speech, et cetera, have a different token ratio depending on the model and the tokenizer. But we went from about 2 trillion tokens to 15 trillion tokens. This is one of the most dense is the best way to describe it, the most amount of data that's been stuffed into a model that size, even today, right? And so you can think of it as you take a model architecture and you actually train it with a ton of this public data, and how the more you train it over and over in different kind of waves towards getting to a final run, you're actually making it better and better and better. And interestingly, one of the things we talked about in the Llama 3 papers is we could have kept on training it. Now, there are not that many companies that spend that many GPUs to continue to train this thing. As a good example, I'll give you a kind of a range. Llama 2, when we trained it, one training run, there's a lot of ones you train it and it like fails and you got to start over. And one training run was roughly somewhere over 3,000 GPUs. That kind of gives you kind of a scale, right? The Llama 3 code base, don't let the sizes of the model fool you because it's roughly the same size, right? 7 billion, 8 billion, 70 billion. Llama 3 had 10 times the number of GPUs training them, right? So why does Meta spend so much of a focus on taking all these GPUs? It costs a lot of money. I think you guys know. You guys are many of you who do research or you're on the production side. Those training on all those GPUs costs a lot of money. And saturating the model with all that data is purposeful, right? And here's why. We want the best, smallest model possible. We don't want the best, biggest model possible. Guess why? We have over 4 billion users. They're using, there are not 4 billion users using our Meta AI, but we are already starting to see a ramp. So we want the most efficient models because it costs us a lot of money every time we're doing inference. So, so in that same way, we've biased towards making the training the one-time big, problematic, spend a lot of money, and save money on inference because the scale of inference is huge. As end users are using it, consumer side and even internal users are using it. And so that's our North Star with Llama. That's one of the things that not all open models are the same. There's a reason when you see that 15 trillion parameters that you should be like, what is that about? And that's the reason. That's the backstory behind it. Because inference costs a lot of money, especially for us when we're running a big consumer business. Nice benefit is because we open sourced it, that same model you can utilize and have low inference costs for your business also. That's the kind of cool thing about it. There's another thing that I want to point out is the 10 million human annotations. Probably many of you, I hope I'm not boring many of you, you know that when you go from a pre-trained model to that instruct model, you're doing a lot of supervised fine-tuning, which is basically telling the model, this is correct, this is incorrect, where is the Eiffel Tower? It's not in Madrid, it's in Paris, et cetera. And you do reinforcement learning, right? The model gave these 4 answers, which one is better, right? Guess who does that? Humans, all of that. That's not like some computer, right? We do have some synthetic kind of feedback loops, but it's humans. That costs a lot of money, and it costs a lot of time. And the scale of that is only increasing as well. And you can just literally see, we had over 1 million human annotations in Llama 2. We have over 10 million in Llama 3. And that just really relates to quality at the end of the day. The quality of the instruct model, or the chat model, or the create your everything model. And then, of course, we also increased the context length to 8,000, and what you can do with the prompt. This is an eye chart. I won't show that. When we released the model in April, it was kind of leading all the benchmarks and state of the art. Maybe even more importantly is that within the human evaluations, around 1,800 prompts, when we compare the Llama models to Claude Sonnet, Mistral Mixed Medium, GPT 3.5, and even Llama 2, almost all the average times the Llama 3 models came out better as far as the human evaluations of the output. So what does this really mean to you? We're open sourcing the Llama models, but as I mentioned, all that goodness that we're putting in, you can leverage really kind of turnkey, both using standalone tools or when it's integrated into a platform like the Mosaic ML platform, right? So again, hopefully some of this is not too repetitive for some of you. When you think about a pre-trained model, what you're doing is you're taking a corpus of the web data. And by the way, it's not just like you just take some web data and throw it in, right? You have to curate that data so that you throw out crappy stuff, redundant stuff. You want to kind of bias it towards certain things. And so you take that data, you train the model, on that 3,000 or many more GPUs that I talked about, and you get this raw model, this pre-trained model. By the way, the reason we release the raw model is sometimes in certain industries, you want the raw model to then do more things for them too. Things like life sciences, things like finance. You might want to actually work on quant stuff, which you'd want the raw model, or like drug discovery, you'd want the raw model. And so we do release the pre-trained models. But the pre-trained models for the larger part of the world is probably not enough because you're not getting I like to say this answer because this is really true. We've asked our pre-trained models. If you ask the pre-trained model about Crocs, you're as likely to get an answer back about the shoes as you are about crocodiles, right? But it literally is true. You can ask, if you can find some pre-trained models, you can over APIs on the web. But so it's really through the supervised fine-tuning and reinforcement learning that you actually take and kind of fix the model and like do a second training run, right, with additional data. It's a second step to make it the more instruction following, make it the usable model that you and I think about when we think of a model. And that's the type of thing that if you asked about Crocs and if the context was you were talking about footwear in the previous multi-turn conversation, it wouldn't talk to you about animals. It would talk to you about foot gear, right, et cetera. But so it is for most of industry would be taking this fine-tuned model, this conversational model, and using it as is. We have many examples of companies that are using it as is, or taking that and then applying your own data and then fine-tuning it further. So yes, you can use it as is. Yes, you can use it with a RAG-based system, just overloading it with vector-based data on the prompt, or you can use it to fine-tune it. And so that really moves the model much more from a generic something to kind of your own model. And remember, because we've opened it, with a very permissive license, that's your model. That's not Databricks' or ours or anybody's, right? And including when you're using it on the Mosaic ML platform, it's your model, right? Which is really, really important because at the end of the day, it's not only your data that going through the model, but you want to be able to have that model to be able to move it around and from a portability and even software engineering 101, know which versions you're using where and things like that. Now, interestingly, one of the ways you can fine-tune just got a lot easier. I'm moving a little bit away from the model side to more the fundamental stack side. So PyTorch is what's used by our engineers and many other engineers to write these models, train these models, run these models. It's kind of like the engine. everyone says AI framework, but it's really like the engine, right? And so PyTorch just recently in April, also the PyTorch team introduced essentially a one-line way to, instead of stitching together the different PyTorch features to tune a model, like here's my model, here's my data, these are the kind of parameters I want LoRa, fine-tuning, et cetera. You don't have to think about any of that. They literally have introduced a kind of an overarching library called TorchTune within the PyTorch framework that will make it super easy to fine-tune a model like Llama 2 or Llama 3 with your data and make it your model. So look into that as well. And of course, some of these kind of technologies are also in platforms like Mosaic ML. All right, I want to switch gears a little bit and talk about safety and responsibility, because there's a lot of different things in what makes these models different. One is, the core model architecture and the AI data scientists, what they're doing. Second is all the data used to train it, on all those GPUs. Third is all the annotation work, or the supervised fine-tuning and RLHF. The last, and maybe as most importantly, is safety and responsibility. And safety and responsibility is kind of really a circular, never-ending thing, right? You're always doing safety fine-tuning, but we're always also doing red teaming towards making the models more and more safe. And safety is different than actually when you're thinking about correctness, right? Safety is about making sure that the models don't output, malicious information or things that you wouldn't want it to output. Now, by the way, I think all of you can also use a web browser and do a search and get to some of these exact same pieces of information. But we want to make sure that it's just not super easy to get towards that kind of information. And so we take a very, very open approach here as well. And we've done this in a couple of ways. Well, first of all, at the model level, we are working on making sure that we are defining the problem, preparing evaluations to catch issues with the problem, and then fixing them in the next version of the model itself. But we're also taking a system-level approach, and I want to talk a little bit about that in the next slides as well, because it's not just about the model itself. Within the model itself, one of the things that we've tried to espouse is that there should be more evaluation benchmarks from the industry that the industry uses together to be able to understand what are the bad prompts, what are the malicious prompts, right? So that we can make sure that our model doesn't react to those. So we kicked off an effort with IBM something called the AI Alliance. And the AI Alliance, it's a website and all this stuff, but the real goal of the AI Alliance, there's actually two goals of the AI Alliance. One is gonna put you to sleep, it's a little bit boring. It's making sure policy and members of policy within governments understand what the AI is not gonna kill you tomorrow, right? So that's one, that's not nothing to do with science or tech. But the second part of it is all about figuring out with industry, what are the evaluation benchmarks that we need to make sure that models, it's almost like the model testing toolkit, almost, right? And what we kicked it off was with cybersecurity benchmarks. And what we're already seeing in the working groups now are other companies adding things like life sciences benchmarks and like chemical warfare benchmarks and things like that. And so these are the kinds of essentially grouping of prompts that we want to group together. And it should be something that works on any model, right? It does not specifically to Llama. But it's as specific as we're using these benchmarks, or cybersecurity evals, as it's called in the AI benchmarking industry. We're using them also for testing for Llama releases, Llama 3, and then in the future, Llama 4. And so that's at the model level. Beyond that, there's even more that you can do. You could actually, if you were really invested in this area, I'm just saying like us, you could take a model and fine-tune it to be a prompt protector. What I mean is a prompt that goes into the model. So we did just that. And I remember I showed you when we released Llama 3, We released, the foundational model, but there were two models over there. One was the instruct model. The other one was Llama Guard 2. What is Llama Guard 2? Llama Guard 2 is a Llama 3 model, 8B model, that we purposefully trained further to look for malicious prompts. And why is this really important? Because at the end of the day, all of us, all of you, many of you are on the engineering side, will be developing systems based on not just like one LLM. Oh, I throw in an LLM, it just works. No, it's a system of LLMs that makes up, people are calling it agentic workflow. It's just a fancy cocktail party way of saying I'm doing software engineering 101, right? Just good engineering is like, hey, I might want to have a module, it just happens to be LLM based, that looks for bad prompts so that so if it's bad prompt, it just doesn't process it further. If it's a good prompt, process it and take it to the next LLM that actually does the processing, right? I'll give you a real world example. In our own Meta AI, some of you have used Meta AI, I hope, Actually, if less people use it, that's good because it's lower cost for Meta. But if you use it, it's actually good because we want you to use it. So Meta AI is our product, right? Meta AI is not, it uses Llama and more, including Llama 3 now. But Meta AI, you can use it within WhatsApp and Messenger, and now it's even in the search bar of Facebook and Instagram. And you can also go to meta.ai, it's a web interface, and use it. It's actually pretty good. I use it almost like 3 times a week. With Meta AI, it is not one LLM. It's not one Llama. I'll give you a little view of what we've done from last year. You actually have first an LLM, a Llama 3 8B, that actually is what we call it the orchestrator LLM. It learns intent of what the user is trying to do and maybe does essentially the equivalent of goes and gets the additional information that has to vectorize into it's like the RAG preparer, so to speak, if that makes sense. All that gets pushed to a safety model, which is a Llama Guard 2, to make sure that the prompt and some of the things that we're passing through are not dangerous data. If those pass through, then we send it to the answer model, if that makes sense, which is a Llama 3 70B model. And that comes out, and because our use case is more messaging and short, we then send it to a Llama 3 8B to concatenate the response, right? Rewrite this awesome, great response in a better way. Those 4 models work every time you click in something into Meta AI. And I'm sure all of you will be doing similar kind of things. And remember, if you're actually doing a business analytics search, you don't want to concatenate. You might want to actually have another model that says, expand this even more, right? And so, but I mentioned this is because safety this kind of thing like Llama Guard should be on all your systems, right? It's not like optional, right? And it's something that is really kind of very inane to how a malicious user, I guess you could say, would want to try to get through the system. So in any case, Llama Guard is another way we're tackling safety. We're having it built right into, having a model that's built for safety. And we did this not only for text, we also did this for code, because it could actually generate, the main model can also generate erroneous, malicious code. And so we have essentially the equivalent of a Llama Guard for code that we call Code Shield. I know it's confusing. It's why did we not call it Code Llama Guard? Don't ask me. I don't work in product marketing, but that's what that is. If you and again, we've open sourced all this as part of the Llama project. All right, all of what I just told you is the good news. Now for the bad news. The bad news is we don't make any money on Llama, so we don't actually support end users directly on Llama. I will say though one thing: we love to hear about end user stories and highlight them on the Llama webpage. So if you are using Llama in a production setting, please reach out to us. That's great. But because we have a staff of people that are working to help enable our partners who are the ones who are working with customers on bringing Llama POCs and Llama in production, right? Or AI use cases in production. And so yes, we have self-service kind of resources like getting started guides and recipes, etc. We also have, of course, working with our cloud and hosting partners like Databricks, and even some of our global system integrators, folks downstairs like Deloitte that you saw and PwC, we're working with very closely so that they know the best techniques of how to use the models, because every model architecture is a little bit different. What you want to do for fine tuning or RAG or the different kind of instruction following it will follow. And this is just some of the companies. There's more companies than this, but of course you can only get logo permission from some of them. So these are the companies some of the companies that we're working with within the Llama ecosystem. I want to talk a little bit. So that's really all about like what we have today, right? I hopefully I gave you a little bit of view of why we released Llama. What is there today, especially with Llama 3, the pre-trained and the fine-tuned models, how you can use it, how you can fine-tune it, a little bit about how you should also be thinking about safety, whether it's our components or otherwise. And then, of course, working with Databricks or otherwise, you can use the model, fine-tune the model, keep the model on your data. So it's your model, your data, not just your data. It's your model, your data. But I wanted to give a little bit of a view of where we think all of this is going. So first and foremost, we have the monster of all models that's still training right now. So in April, we trained and released the first Llama 3 models. The first two were the 8B model and the 7AB model. We are still finalizing the training and fine-tuning of a third model. This is, I think, we were saying 400, and then the big boss, Mark Zuckerberg, he was on a blog, and he's like, oh, it's 405B. So, I mean, if he says it, I can say it right now, right? So we're all like, oh, you can't say it. And then he just goes off and says it. So, what do you do, right? So it's a 405 billion parameter model, and it's going to be extremely, extremely powerful. Most interestingly, you can actually take this model and fine-tune it into doing something really, really, it'll be like the super powerful. Think about if you could fine-tune and then further distill from teacher-student type of approach, smaller models from it. It's going to open up a lot of really cool possibilities in the industry. And we haven't announced anything as to when it's coming or when, how we're going to open source it. But stay tuned, because it's pretty exciting. It's finishing up the training and fine-tuning process as we speak. So that's one vector of what's coming in the future. Another vector is with the smaller models that we've already released, there's going to be updates, and our kind of North Star is to add support for more languages. Language, by the way, is not at the pre-training stage. Yeah, it can help at the pre-training, but it's really a lot about the fine-tuning work. So these, supporting more languages is not just like check, check, check. It requires a lot more effort and budget and things like that. But multilingual is definitely something that is coming. And as we look forward, also you'll see Llama models that are multimodal. Again, that ones we're going to open source with different modalities like image handling, speech handling, and perhaps in the future even video handling. But these will be, things that will roll out throughout this year and next year, and all still with the foundation of text-to-text, of course, being there, et cetera. I like to note that we can't really call them multimodal large language models. That kind of makes no sense, right? So is it multimodal model? Or like, what is it, MMM? It just doesn't sound right anyways, right? But that's what we're all moving to as an industry, and including with Llama 3 point something, Llama 4, and et cetera. The other thing that I wanted to leave you with is the fact that these large models, whether it's GPT-4, GPT-4o, Gemini, and Llama 405B, this will be at that level, right? These large language models, there's a lot of naysayers out there that, they're going to control our world, doom and gloom is happening. I, for one, believe we're very far away from that. I believe that for many reasons. I believe that also because I work with a lot of people in our AI research teams that are working on some of the cutting edge new model architectures. And of course, some of you might know Jan LeCun or you read about Jan LeCun. I highly recommend seeing some of the podcasts that he's part of. He puts out a pretty, very, very clear agenda, which is what our AI research teams have been working on, that we are still really, really far away from what a lot of people call AGI. We call it advanced machine intelligence. And we're really far away because there's a lot of still components of, I'll call it core tech that the models don't do. So yes, we're getting pretty good at language. We're still not fully there, right? It's still things hallucinate a lot, et cetera. But we're still getting good at language and better. But perception, and this is not just classification, but really perception of what's going on in the world through vision. Language is what's going on through the world through words. What's going on in the world through vision? That is called perception. That is not a solved thing. And that's a big area. I mean, Jan likes to say that we process as humans, as a 3-month-old baby, more data than what we process in a lifetime of language. So imagine how much you're learning and operating with. Many animals don't speak, but they do quite fine through perception. So that's a big area of research for our AI research team and many other leading research organizations. Second, after that, that's not happening right now, is planning, right? There are some basic rudimentary planning models. The autonomous driving systems are probably the first that come to mind. But there is just so much more nuance than just one roadway, et cetera. And as you know, they're not at what they call level 5. But there's much more around planning. And there's a lot of research going on around that. And it's going to be years before AI models, systems know how to do that well. The third is around more physics and navigation. And that's different, understanding the differences of the different surfaces and things of the world itself. And one of the things we would put in there is also even memory systems in there, knowing that this happened a little bit before, et cetera. And then the last is really less so, is making sure that we have all the alignment tools to really make sure human values are as part of that as well. So in any case, there's a lot of still steps before our robot overlords come and take away our jobs or ruin our world itself. And so everyone gets fixated on language, but you will see different standalone models, not the iterations of the language models, that are going to start addressing some of these areas. And so we're really, for some of these other areas, probably where we were with language models in the BERT and Transformer 1 days, which is about 5-6 years ago. Very, very early days. And so, there's a lot more that's coming from the research teams, not the production, engineering teams, but the research teams of where we can see this is going in the future. And with that, some success stories. We have a bunch of companies that are using Llama 2 in production right now. The Grammys used it for a rating system. Niantic uses as a non-player character in their game called Peridot. Audi is using it in Germany as a customer chatbot to recommend which cars the end user should look into. Shopify has been using it as a customer service agent helper. Summarize what the end customer bought, so the person behind the keyboard can respond in the correct way. We have uses for cybersecurity, uses for education. It's all over the map. And so it's pretty cool to see some of these use cases of both the base model or the fine-tuned model. Last but not least, we do have a setup and getting started guide. So you can take a picture of that QR code. And of course, you could also use Llama 3, both the Llama 3 models. Actually, all of the foundational and the additional Llama 3 models are part of the Mosaic ML platform. You can also use it there as well. And I have 27 seconds left to go, so thank you very much. Perfect timing.